If we slice open a cone, then it exposes 4 types of curves. If I slice it horizontally, then the exposed area is circles. If I tilt a little bit, and then I get these ellipses. Then if I slice it parallel to the sides, then I get these precisely parabola. Then if I tilt a little bit more, I get these points that look like parabola. They're called hyperbolas. And these 4 types of curves correspond exactly to the second-degree equations of this type, except I'm not talking about these degenerate cases, okay? And these 4 types of curves are related to distance because they can be defined through distance. And to go back on the algebra, which we'll look at, I'll call completing the square. We start with a circle. The circle consists of points, all the point x, y, that distance r to a center. So if I know the center and r, I put into the distance formula, the x, y must fit this equation. It says distance to the center is r. Square both sides, I get the standard equation. It's called a standard equations because if the equation is presented in this manner, it's easy for me to read the centers, read off the centers and the radius. In particular, in this case, 3 minus 2 is the center, and the radius is 4. And that I can easily picture and graph. And on the right-hand side, the rightmost points are F4 to the 3, I guess 7 minus 2. So that's the rightmost point. You can do the same with the other 3 points. Now, and if on the other hand, if I have equations that you have pictures, I can easily make up the equation. So I know the center, the radius 5. So plug into these standard equations. Center is minus 1, 3, radius 5. Now I get this equation. When I expand this equation, I get this. Now the question is, how do I go backward if I'm given this equation? That we do it by completing the square. Here's how we complete the square. Given these 2 terms, what do I do to make it square? Well, we add half of 2, which is 1, and square that. And the other one, half of minus 6, square that. So in other words, if I add 1 and 9 respectively, I get perfect squares. So this is how I go backward. Given that equations expanded, here we how we go backward. We'll group the x. We add half of 2, which is 1 square, add 1. Add half minus 6 is 9, and 3 square, that's 9. So or to both sides. And now, and I get this perfect square. So voila, we get back to the standard equation. Therefore, I can graph the circle and as before, as the circle. Okay, and so that's it. Bye-bye.